Okay, now we're live. Forgot to start the broadcast. We're good now.
Okay.
Okay. So, yeah, I'm going to write these down. Are you starting on the question?
Yeah, I'm just I'm looking at the equation right now.
Okay. I might have to watch a portion of this video because I'm kind of lost.
That's fine.
How's yours coming?
I'm stuck.
I just drew a triangle, got the other side, so I know cosine A is 4/5. Uh, that's as far as I got.
Okay, so how did you find cosine?
I did the triangle thing where you draw the picture
Okay.
and then draw the triangle out toward that quadrant. Filled in the two sides that I get from the sine A. So if
Okay,
sine A is 3/5, then the hypotenuse is 5. The opposite side is 3, right?
how do we know that?
Because sine is opposite over hypotenuse. Right?
Oh, that's right.
Opposite's 3, hypotenuse is 5.
Okay.
Yeah.
And so we're Pythagorean theorem?
Then we do Pythagorean theorem, get the other side. And so, yeah. So if the hypotenuse is 5, the opposite's 3. When you do Pythagorean theorem, the other side is 4. I'm calling that x. X is 4. And then if we want cosine of alpha, then we would just take adjacent over hypotenuse, right? Which is 4/5, 4/5. So I know that much is true. And then I'm not exactly sure where to go from there. Unless I just plug it into the formula and do like the plus and minus versions of it.
Well, okay. So this part I kind of remember, depending on what quadrant it's in, is what sign you get it.
Okay.
So, of course, I think that might also be dependent on whether it's cosine or sine. So I can't remember if it's positive or negative.
Okay.
Uh, I think I'm just tired of the whole semester.
Mm-hmm. Yeah.
I just want it to be over.
Yeah. Let me skip this. Okay. So if you're using cosine and cosine is positive in that quadrant, you're going to use the positive sign.
Mm.
If cosine is negative in that quadrant, you use the negative sign. And then so cosine is going to be like, it'll be positive on the right half of the unit circle, negative on the left hand. And then sine is going to be positive on the top, negative on the bottom.
Okay. So this one's positive then?
So this one is no, cosine's negative in that quadrant.
Oh, okay.
In quadrant 2, right? Because it's on the left.
Okay.
I guess my question is, where do I apply that? Does my cosine alpha have to become negative immediately since we know it's in that quadrant? Yeah, I mean, I guess. I think he did that in the other video. Yeah. So cosine A is negative 4 over 5. And then we'll do the formula. Well, I got an answer. I don't have a clue if it's right. I'm kind of doubting it.
Yeah.
Let's see. I almost got it right. I just had a negative sign on it that I shouldn't have had, and I'm not sure
Oh, you
why.
too?
Yeah, I got
1 over square root of 10.
yeah,
Except,
I got I got negative.
with a negative.
Yeah,
Yeah.
negative 1 over
Yeah.
square root.
That's what I got.
You got negative or positive?
I got negative.
Yeah, I mean, I don't understand at what point we apply the negative because, I mean, I feel like I applied the negative twice when I drew the triangle and once when I did the equation. But I thought I needed the negative in the triangle because it's a -4 that we found
Uh-huh.
technically in the unit circle. So that part's throwing me off.
Huh. Well, this whole thing's pretty much throwing me off, so you're probably doing better than I am.
uh, Anyways, we applied the negative twice. That was wrong. So let's just keep in mind on this kind of equation, apply it once. And then we'd get it right.
Yeah.
Okay, well, hang on. Let's see what I would get if I hadn't done the negative. I would get 9/5 over 2. Yeah, I would have gotten a different answer. I would have gotten 9/10. So -3 over √10. That's not right. So no, I mean they selected the positive there, and I don't understand why. They selected the positive on the plus or minus square root part. Otherwise, they would have gotten a completely different answer if they hadn't made the x -4 and the cosine A -4/5. Like, ugh. Hang on, I think he's doing a similar question on this very last part of the double and half angle. So I'm going to see what this looks like.
Okay.
Uh, he went about it differently than I thought he would.
Oh,
So I'm not sure how to do it because the half angle of a cosine on the other side, it still involves a cosine, and we're given sine, right?
okay.
So like you can't just plug it in, and on this example, you just plug it in because it gives you a cosine.
Okay.
Yeah, so like if you look at the half angle formulas, sine of x over 2 equals plus or minus 1 minus cosine x divided by 2, right? So like there's a cosine in the other side.
Oh.
And then if you do the cosine, there's still a cosine on the other side. So like sine of A equals 3/5, just it makes you have to do it differently than any of these examples show. So it's just a tricky one.
Yeah.
All right, well, let's, what's next? I guess, that still confuses me like crazy. I don't like that.
Yeah, I don't get it.
Okay. Oh, what the heck? In the extension problems, it shows the answer, like like you didn't have to go to um, the key to see the answer.
Yeah.
I didn't realize that. Like if you look at number 8 on the extension problems, it just tells you that it's 1 over root 10.
Oh.
I mean, we were supposed to find that still, but anyways, it's just weird.
Oh. That was a-
Uh,
Oh.
so cosine A over 2, is that an angle or a side? On 3 it asks. So side length is what the key says. I don't know, man. This is confusing stuff.
Yep.
All right, let's try number 9.
Okay. So find sine alpha plus beta, given sine alpha is -3 over 5 and is in the fourth quadrant, and cosine beta is -1/3 and is in the third quadrant. Okay. So some indifference identities.
Wait a minute, what? So one can be in the fourth quadrant and the other can be in the third? That's weird.
I thought I knew this, but actually I really don't.
That's the best, isn't it?
No. So now, if it's just sine of alpha equals -3/5, are we just substituting the -3/5 for alpha or for sine of alpha?
It's sine of alpha, right?
Okay.
So we could do the triangle thing. Um, yeah. I don't know. Never mind. It's such weird, man.
So we're still trying to find cosine alpha and sine beta?
Uh, in theory, yeah, we'll need them. Because if we look at the formula of sine of alpha plus beta, it equals sine of alpha plus cosine beta plus sine of beta times cosine alpha. So
Yeah,
we really need all four.
right.
So yeah, given sine alpha and sine beta, we need to find sine beta and cosine alpha in order to finish the equation.
Okay. How do we find those, though?
Using the triangle trick.
I hate the triangle trick. Triangles are dumb.
It's easier than algebra a lot of the time though. It's just hard to know when to use that versus algebra.
Okay, so sine of alpha is in quadrant 4. Cosine beta is in quadrant 3. So I think I'm doing this wrong.
What part are you stuck on?
So doing the Pythagorean theorem.
Mm-hmm.
So the way that I set up my triangles is so sine's in the fourth quadrant.
Right. Think of
So
it as alpha. It's like draw your first triangle, that's your alpha triangle. And
yeah,
then like your other one's beta. So like you're using sine of alpha to find that triangle. You'll get the third side and you you have sine of alpha from that. Now you want cosine of alpha
yeah,
from the same
yeah.
triangle. Like don't try to find sine of beta on that triangle. You're not going to get it, right?
Yeah. So, okay, I guess just tell me if this sounds right. So
Okay.
for when I was doing the sine triangle, I came out with x equals 4, and then for the other one, I got x equals 8, and that doesn't sound right to me.
I got x equals 4 on the first one
Okay.
for the alpha triangle. I'm still doing beta though.
Okay.
So you got on the second triangle, did you get the third side as 8, you said?
Yeah.
Okay. That's y squared. Like you need to square root it still. So I got square root of 8.
Oh.
Yeah.
Well, this, what? Because so what I did, I set it up like x squared minus 3 squared equals 5 squared. And then I added 3 to both sides. So I got x squared equals 5 squared plus 3 squared. And then I square rooted both sides. So I just got x equals 5 plus 3. And then it just comes out to x equals 8.
I'm really confused. Why did you combine both triangles? Like
And then combine both triangles.
where are you getting 3 and 5 from?
Oh, wait, hold on. Oh, wait, no, this is. What am I doing?
So your beta triangle, let's start over. Cosine beta is -1/3, right? So in the
Yeah,
third quadrant, so you go left 1, your hypotenuse is 3, right?
the hypotenuse is 3?
The hypotenuse is 3.
Oh, for cosine,
The
you mean?
cosine. Yeah.
Okay, yeah.
And so in Pythagorean theorem, you're going to do, right, -1 squared plus y squared. I'm calling the third side y. So y squared
Okay,
equals 3 squared, right?
yeah.
Well, 3 squared is 9. -1 squared is 1. Y squared we don't know yet. So you have to subtract the 1 over. 9 minus 1 is 8. So y squared equals 8. And if you square root that, y is square root of 8. Are you following that?
Yeah, I think okay, so I think what we did differently was I uh I didn't combine them first. I square rooted them first.
Oh yeah, I did that. I did that wrong too. Yeah, you have to apply the square first, or it messes things up.
Why can't you just freaking do that? It's much easier and cleaner. It looks better.
Yeah, it just messes up the signs though. It's annoying, but
That's fine.
yeah, apply the square first, or it screws things up.
Okay, so for the cosine one, it's square root of 10 then, right?
No, 9 minus 1.
9 minus 1.
9 minus 1. So it's 8 and square root of 8, not square root of 10.
But I thought we had a. Wait. So you set yours up as -1 squared plus x or y squared, right?
Uh-huh.
And
Equals 3.
so equals 3 squared. So when you add 1 square to each side,
No, apply your square first. So
Oh.
what's the square of -1?
Okay, it's just 1, and then you subtracted
And then you
1
subtract it.
from each side.
Yeah.
Okay, I see what you're doing now.
Yeah, that screwed me up when I was watching the videos and I was trying to follow along. I'm like, why
Yeah.
didn't it's a negative, right? And I figured out you have to do that first. So
Okay,
yeah.
so for cosine, it's x equals square root of 8. Okay. And then the sine one, sine equals 25. Minus 9, that's 16. X equals 4. Okay, got it. I'm caught up.
Okay, so now that we have x for both of those triangles, right? We have the third side for both of those triangles.
Yeah.
Now we can find, like, let's look at the sine alpha triangle, right?
Okay.
Let's get cosine alpha from that. So cosine is adjacent over hypotenuse, right?
Yeah.
So that's 4/5. So cosine alpha is 4/5. It's in the fourth quadrant. Cosine is positive in the fourth quadrant, so we leave it positive. So that's our cosine alpha. And then on the, are you following that?
I think so.
Okay. And then on the beta triangle, we want to find, we already have cosine beta, it was given, so we want sine beta this time.
So
Sine,
that one's the square root of 8 over 3?
yes.
Okay.
The square root of 8/3, but sine is negative in that quadrant, right? So I think we have to put it as negative square root of 8/3.
Okay.
And then from there, we have our four pieces for the equation, so we just plug them in now. So sine of alpha is -3/5. Ooh, I drew my equation wrong.
Okay. I think I got it.
This is Harry. Did you get 3 minus 4√8/15?
Nope. I got 3 plus 8 square root of 2 over 15.
3 plus 8 square root
Oh,
of 2.
hold on a sec. I screwed up a little bit. It's actually, it'd be 3 minus 8 square root of 2 over 15.
Where did you get 8 square root 2? What part did that come from?
So you have square root of 8, but you can pull out a 2 from that, since 2 times 4 is 8, and then square root of 4 would be 2.
Oh, good call. Okay.
So, and then that 2 times the 4 in 4/5 make it 8 again. So you're left with negative 8 square root of 2 over 15.
Okay, so we didn't fully simplify our sine, well, our y or our sine beta, huh?
Yeah.
Okay. Whoops, I didn't even consider that possibility. So that's 2 root 2, correct? Negative 2 root 2 is our y.
Yeah.
Okay, so 3 minus 8 root 2 over 15.
Yep.
Okay. Does that check out? 3 minus 8 root 2 over 15. Yay. Sweet. Let's take the quiz.
I'll go with that.
I feel solid enough, probably, depending on the question. Let's just see let's see what the quiz questions are, I guess. Okay, so we have another similar one for number 1. Verifying the identity, that will be some substitution and more substitution. Cool. We didn't do any of that. Secant squared of x. What in the world? That's going to be so obnoxious to do number 3
So I don't know what you're talking about right now.
on the quiz.
Yeah, my computer's struggling a little bit right now.
Oh, okay. I was just looking at the quiz questions. Number 2 and 3 look really obnoxious.
Oh.
But I guess we'll get to that when we get to that. So let's
All right.
start with 1.
Okay. So
Okay. And what's the square root of 576?
24.
Is it really?
Yeah, you said 576, right?
Yeah.
Yeah, it's 24.
Oh, okay. Well,
Yeah.
that's more convenient than I thought it would be.
Yeah. I actually kind of have an answer right now.
You have an answer?
Yeah. Though I'm not sure. I might be able to simplify it even more, but I'm not sure. But anyways, so far what I got is 416 over 425.
For the cosine alpha plus beta?
Yeah.
Oh, wow.
Yeah.
Well, you're way ahead of me, so I guess you can either try and simplify it more or go on to number two. I want to see what I can get.
Okay.
Plus, I have to write it down anyway.
Yeah, I gotcha.
Okay. Okay. Did you get negative 304 over 425?
No.
What did you get again?
Uh, I got 416 over 425. Oh, wait, hold on. I may have screwed up.
Yeah, there were some negatives there.
They're both negative.
Yeah.
Okay, so that's a negative 24 over 25 and a negative 15 over 17.
It's a positive 24 over 25.
Wait, but it's in quadrant 4. I thought that was negative.
Yeah, but we're getting cosine from that. Cosine's positive on the right. So
Oh,
just think of the triangle. I realize this is easier because like the triangle's pointing right. That length is positive on the unit circle, right? Like, or like on a graph, that's a positive distance, positive vector, I guess. So 24 is positive, and then on the other graph, on the other triangle, it's negative 15, right? Because it's going left.
yeah. I think the thing that
Um,
trips me is we start off with the sines and we're getting the cosines, so I think that's where I kind of screwed up there.
yeah, there's a few different ways to think of it, so I don't want to confuse you, but
No, it's all good. So it's negative 304 over 425.
yes, that's what I got.
All right. Yep.
Cool. And I imagine there's no simplifying that.
I don't think so.
Okay. Did you get anywhere on two?
Yeah, I'm still trying to figure it out, but I think I'm getting close.
Okay. I'll get started. Oh no! I have inverses on each side.
Inverses.
Like I have a 1 minus on one side and then a 1 plus on the other side. So they're like inversed from what I was hoping I would find. Does that make sense?
Not really.
Hang on. Oh, never mind. I got it. Yeah, I got it.
Okay, hold on.
I'm going to be best off explaining this, showing you
Okay.
the work.
Okay, so what did you get?
I got 1 plus sine y cosine x over sine x cosine y. And those matched on both sides.
Oh. Wait, say that one more time.
Oh, I'm sending you a picture. This will be easier.
Okay.
Yeah, it was confusing at first because the order's different, but like it's, 2 times 3 is the same as 3 times 2, right?
Yeah.
So it doesn't look the same, but it is the same. I just didn't want to rearrange things, but
So 1 plus cosine x sine y.
1 plus cotangent x.
Oh,
Right.
okay.
That changes things, right?
Uh, yeah, that's not what I got.
Yeah. I'm sure you would have gotten it. That changes things quite a bit.
Yeah, I got to 1 plus cosine x sine y.
Okay. Does that make sense though in the picture?
Uh, I didn't get it yet.
Yeah. So did you start with the right question written down though?
Yeah.
Like the sine x plus y, whatever, equals 1 plus cotangent x tangent y?
Yeah.
Okay.
This last one sucked.
This is awful. Yeah. I don't know which direction to go.
Yeah.
Like, what do you... The square thing screws everything up. This was kind of a mean question to ask us. Don't you think? This is insane. I don't have a clue what to do.
Yeah. I keep on like looking through the different identities. And as far as the identities are concerned, the only things I can see are you can change secant of x into 1 over cosine of x, and then you can change the secant squared into tangent squared x over 2 plus 1.
Yeah. That's kind of where I'm at too. Just that right side, I don't have a clue what to even do with that.
Yeah.
Like, yeah, I don't know what to do. That's just a mess.
Oh, also I got your text and it says message not found.
What? Oh, I didn't realize you hadn't gotten it yet.
Yeah.
It's probably you're using your phone for this Hangout, right?
Yeah.
Yeah, I don't think you'll get it until you're done using data. I think that's
Oh. Alright.
what happens. I'm not worried about 2 though. I'm very confident in that one.
Alright.
Yeah, you could check it out after or whatever, but or I could email it to you. Want me to do that?
It's fine.
I'll just email it. You can see it that way. All right, and it's Gruzwizzle. Gruz.
That's my that's my Gmail. Gruswizzle.
So GRUZWIZZLE.
No, S I or SWIZZLE.
Okay. At gmail.com. Okay. That should be sending.
What's going on? Uh,
Holy nuts, this is getting hairy.
yeah, I don't even know what to do anymore.
I'm just winging it, like doing crazy crap, and I'm gonna see if it works.
Okay.
So what I noticed on the right side is 2 secant x plus 2. You can
Yeah.
factor out a 2.
Yeah.
Then you get secant x plus 1. Well, I know secant squared x plus 1 equals tangent squared x plus 1. So I'm multiplying both the top and the bottom by secant x plus 1 so that I can convert that over to the tangent form.
Okay.
And I'm going to see if it works. That's all I can think to do at this point.
Okay.
Oh, wait. I don't don't think I can do that. Secant squared x plus 1. It has to be minus for that to work. I don't know, man. I feel like it's getting worse.
Yeah.
I have no idea, dude.
Me neither. I don't even know what I'm looking at anymore.
um, yeah, this is kind of a mean question. I hate to throw in the towel, but I have no idea. Hmm.
Uh, yeah. I'm starting to lose it.
I'm not convinced anyone's going to be able to do this.
Yeah.
Well, well, I think we could keep beating our heads up against a wall, or we can just throw in the towel.
Yeah, I'm cool with that. It's getting late.
I mean, I'm not going to get this.
Yeah.
There's definitely a piece we're missing, and yeah.
Yeah.
All right. Well, hopefully we get partial credit for it.
Yeah.
I'm gonna draw in some question marks. I'll tell them that we tried and we beat our heads against the wall for a long time.
Okay.
Yeah. All right. Um, did you understand number 2 though?
I mean, I got an answer. It's just not the answer that you got.
It still could be right.
Yeah, that's what I'm kind of thinking.
Yeah. Like I mean, you could get all the way to the other identity if you wanted to,
Yeah.
or like the other side of the equation if you wanted to, but yeah.
It's fine.
Okay. All right. Well, I don't know what it is we're missing, but we'll hopefully find out eventually
Yeah.
and not get screwed on this next test. Okay. Well, I'll let you go, man. I'll get this stuff turned in and we'll worry about it later.
All right. Sounds good.
Okay. See you, Tyler.
See ya.